All right, so this problem we did in class today, we have the situation where we have a bag of raisins. They cost $4 a pound and walnuts cost $8 a pound. Diego spent $15 on both ingredients. And this is it. So we're supposed to write an equation to represent this formula. And this is the equation we came up with today in class. 4x plus 8y equals 15. This would give us the cost. It shows the relationship between the pounds of raisins and the pounds of walnuts. We're going to use this graphing technology, which is what we were struggling with earlier in class today, but I really want you to understand how to use Desmos. I think it'll be very useful. The reason that this 4x plus 8y equals 15 didn't work before when we graphed it and we were trying to create a table is because we need to solve for y in order for that to work. This is now the equation solved for y. This is what we're going to have to do in our calculators as well, and I'm going to show you how to use those in class tomorrow. But this would be our equation solved for y. So I'm just going to go ahead and delete the standard form of the equation. We're going to go up to this equation. We're going to hit settings. And here you're going to see the option to create a table. So I'm going to click on that table. Now you guys can see that -2 has a value of 2.875. -1 is 2.375. I can change any of these numbers I would like to. So in the graph over here, you can see that we need to find 0 and 0.25. So I'm going to type in 0 right there. Enter. 0.25 we needed to find. Forgot my decimal. It's not picking it up. Enter. Okay, undefined because we haven't chosen a value. We need to find 1.375 on the y side, so let's see if we can punch in something there. And we're not able to punch anything in there, so we're just going to go ahead and delete this function. We're going to make sure we have the other values that we need for the x's, so space, 1.75 and 3. Oh, we don't need that one. So I'm typing in a 3 right there. Okay, and then these are the ones that we don't have. We don't know. We're trying to figure out what they are. So we're just going to delete what we have in there. Okay, and we're going to try and figure it out. So if we're looking at our graph, it won't let me, there we go. When we're looking at our graph, we can zoom in on it and we can try to find this value. So remember in these ones we were supposed to find when y was equal to 1.375 and when y was equal to 1.25. So if we try 1.25, we can click on these points on the graph right here. It's not going to let us select it, but here we're going to try an x value. We don't know what it is. And we're going to put 1.375. I have to make my calculator bigger. See if I can get this down. Wasn't letting me collect my numbers. Okay, so we're going to try some values here. So we can see that it's between 0 and 2. So let's just try 1. You can see, hey, look at that. We picked a good number. So we can type in 1 right here, and we're going to see that we know that this next point is in between 1 and 1.75. So I'm just going to take a shot in the dark and try 1.25. 1.25 does appear to be on the line. So the next thing I'm going to check is the table. I'm going to type in the 1.25. And I'm going to see that it actually is 1.25 is the output value, the y value, once it's plugged into this equation right there that we came up with. So you can see how you can use the table to help you find solutions if you know the x value. It's a little bit more difficult once you're looking for a y value, you know a y value and you're looking for the x value. But this is how a table of values works in Desmos. Once again, you would have to solve for y and get it into slope-intercept form, but we are going to go over that again tomorrow in class, and I'm also going to show you how to use your calculators with the same idea. With all that being said, we were able to complete the table with the amount of one ingredient Diego could have bought, given the other one. This is our reasoning. We would use our Desmos graph to prove it. All right, here's a new piece of information. We started going over this when we were working in class today. This says that he'd bought a total of 2 pounds for his ingredients. With that being said, we came up with this equation, x plus y is equal to 2. Remember, in order to plug this into Desmos and be able to get a table, we need to subtract x from both sides, and we would end up with y equals negative x plus 2. I've always said to put that x first so that you can have them in the proper order and it makes sense for your slope-intercept form. Again, I went ahead and plugged this into my Desmos graph screen. Now we're going to go ahead and edit our settings. For this equation, we can come up with that table right there. And we're supposed to fill this table in once again. The first term we need is 0. The second one is 0.25. Gives us our y value. Remember, in these ones, we don't know our x value, so we're just going to take those out. It says undefined because if we don't have an x value, we're not going to have a y value. And then down here we have, again, 1.75. You can see all these lines are all these points are showing up on our line down there. And we also needed 3. I'm going to delete that one. And now we need to find these 2 points. They're in between 0.25 and 1.75 because that's how they're decreasing over here. You can see 2, 1.75, undefined, 0.25, negative 1. So they're decreasing. So we know that these numbers right here have to be increasing. So we're going to try 1 and see what happens. We get a 1. Our goal is to get 1.375. So we're going to try. So now I've just filled in my table of values over here. In the next question, so we used our graphing calculator, we completed our table. Each of these items, your x and y values work when we plug it into our equation x plus y equals 2. They all add up to 2. The next question goes into Diego spent $15 and bought exactly 2 pounds of raisins and walnuts. How many pounds of each did he buy? Explain or show how you know. You can see that when I bring the other table from our previous equation, the only place that they have the same exact solution is this 0.25 and 1.75. That just goes to show you that that would be your solution. This solution would satisfy both equations, and also if these were graphed on the same coordinate plane, it would just display where each of these graphs would actually end up meeting at that 0.25, 1.75 coordinate. So my question for you is, can you find another combination of raisins and walnuts besides 0.25 pounds and 1.75 pounds that meet both cost and weight constraints? The correct answer would be no, that is not possible. How many possible combinations of raisins and walnuts meet both constraints? Just the one, right? Because we talked about how they would intersect and there would only be one intersection for 2 lines. So this leads us to the next question of this entire unit is, how do you write a system of equations? What is a solution to the system below? So this is how we would write a system of equations. You can see they're both in standard form. They have their x plus y equals 15, their x plus y equals 2. That's not technically always the case, but that's what it looks like here. And then we also, how are we going to find the solution? Well, I mean, as we saw in this one, it's going to be where those 2 lines intersect. Okay, where they intersect tells us the solution that satisfies both equations. In this situation, we have a dining hall that's totaling 25 tables. We're trying to find some situations that relate to quantities and involves 2 constraints. So this first situation with the 25 tables, some of them are long rectangular tables and some of them are round ones. Long tables can seat 8 people, round tables can seat 6 people. On a busy evening, all 190 seats at the tables are occupied. How many long tables X and how many round tables Y are there? With that being said, we come up with these 2 equations, x plus y equals 25 and 8x plus 6y equals 190. When we rewrite these equations to make them look more like each other, it would end up looking something like this. When we see this, we're then going to think about that y is equal to this value. Okay, so once we know what y is in one situation, because it works for both of these, we're actually going to take and we're going to be substituting that value in for y right here. Okay, and hence this is called the substitution method. You can see I took the negative x plus 25, substituted in for y, and now I have this function right here. I'm then going to be able to solve this equation and figure out what x is equal to. This just goes to show you that when we find what x is equal to and substitute it back in and find y, we end up with a solution of x equals 20, y equals 5, which satisfies our system of equations. So meaning that would be where our two lines would be intersecting to meet at the point 25. For this next equation, a family bought a total of 16 adult and child tickets to a magic show. Adult tickets are $10.50 each, and child tickets are $7.50 each. The family paid a total of $141. We can come up with equations for this, and we end up with a plus c equals 16, and 10.5a plus 7.5c equals $141. Each equation is a different part to the system. One way we could solve these would be to graph them. I did plug each of these equations in. The only thing I changed is I let x represent a and y represent c, because that's what you need when you're working with a calculator. You can't see the graph right now, so what I have to do is I've got to be able to zoom out. So there's a significant point right here, and the significant points that we would see in our graph would be our y-intercepts, so you can see both of those. This one is 0 and 18.8. This one is negative 0 and 16. And then down here we have our x-intercepts, which would put it at 13.429. And there's our x-intercept, 16, 0. And then we also have this other point, this point 79. This is our solution to our system. It goes to tell us that the possibilities that satisfy both the first equation and the second equation are 7 adult tickets, which represents a and x, and 9 student tickets, which represents your c and your y value, because I replaced them. So, great job finding the solution when we look at a graph. So far we have used in number 1, substitution. Number 2 is graph. In meeting the constraints, what do you notice about the strategies used by the class? You remember that we used graphing as one of our strategies, as well as substitution. Each of these show where the solution happens for both lines. Why might it be helpful to write a pair of equations to solve these problems? We can easily set them equal to each other and find out what our x value or our y value is. We can also graph them, and we can see where they intersect. So there's just a couple things that we really need to start to understand about systems of equations. If I had classmates absent today, or if you were absent, we're going to review again. How would you explain a system of equations to a classmate who is absent today? What would you say if they asked, what does it mean to solve the system of equations? Well, for instance, here is a graph. Here are two different equations. One is the black equation, x plus y equals 4, and the other one is the blue line, representing 5x plus 10y equals 25. You can see they have the slope for the lines, they have the y-intercepts, the x-intercepts. So which point or points are solutions to the equation x plus y equals 4? Those points would be your point E and your point C. You can see that they are points of my black line right there. Which ones are equations or solutions of my blue line? D and C would be equations of my blue line, or solutions of my blue line. Which are solutions to the system? Well, the solutions to the system are where they both occur at the same time. So that would be your point C. Great job today. I hope this helps you, and we will see you again tomorrow for some more practice.